Hey, angry admins! Welcome back to my channel where I tackle the toughest IT challenges so you don't have to. Today, we are diving into the world of Kubernetes, the powerhouse behind application development, scaling, and management. Whenever you are a seasoned DevOps warrior or coding crusader, stick around so I can guide you through the setting up Kubernetes on Ubuntu machine using EC2 instances. You may ask me why, because I was curious about the process of installation of Kubernetes, and I was searching through the guides, but all the guides and videos I found online, I followed them to the dot, and I always end up with this error. And after about 3 days of investigation, I find out that this error, in my case, was related to network plugin. So I had to redo some steps. The many videos won't show you that particular step when you have to configure the network plugin, and that's why you will end up with the error like myself. Anyway, if you follow me, I can promise you that after end of that video, you will have your Kubernetes cluster up and running. Okay, let's get those applications running smoothly, shall we? What's Kubernetes? Very simply, imagine a system so smart it automates the boring stuff in app development and management, making your life easier. Developed by brains from Google and now under the CNCF wings, Kubernetes is your go-to for container orchestration, letting you focus on building great apps instead of sweating over the infrastructure. Let's have a look on the screen. So I will show you how to start from scratch. So we are in the panel on the AWS on the EC2 instances. So I have some instances like running, but this is not important. We will build a new instances. So I'm going to launch instances. And now I will name them. We will choose which operating system. I will choose Ubuntu. Okay. Now we need at least medium configuration, but I will go for large. Or you can go for medium. As you can see, that's the prices per hour. So you can choose whatever you want. Now, the keeper. I already have a keeper which I'll be using, but if you don't, you have to generate a new keeper here and download it. This network. Now, I am in the sandbox, but this is not production environment. So as you can see, allow traffic from anywhere, I cannot use it. If you on your home lab or on your non-production environment, to avoid any complications, by all means, use anywhere. I have to use my existing security group, which I have bunch of rules, allows me to access those instances from specific IPs. And number of instances, let's do 3. It will take a few moments. So as you can see, successfully initiated launch of instances. So let's go back to instances. It will take few moments. As you can see, they are running. So I think they will be in the pending state. Yes. We can prepare those instances in the way that we change the name to understand which server is which. So I can do this as a master, and this as a worker 1, and this as a worker 2. What I need as well, I need to note the IP addresses. So we are going to use private IP. So let me just copy to my personal notebook. So this is for the master. Okay, now once I have this noted, let's see how we can access them. If you click on the instance and we know it's a master node, we click on the connect. And we are going to use SSH client. As you can see here, it gives us the steps, but one of the important things is this one. If you download your key, you have to change permission to 400. If you on the Linux machine or on the Mac, you can open terminal and just use this command. If you are on the Windows machine like I am, the command will be a bit different. You have to open your CMD or PowerShell. You have to go to the directory where the key is located, and then there is a command you have to use, which is this one, here or here, and that command will remove inherited permissions. And now the new command, that one, grant read permission to the owner. So you are given to those commands and your key will be ready to use. Now, as I mentioned, I am going to use a PowerShell to act as my terminal. Okay. So what I can do, I can just copy that command from example and paste in the PowerShell. And yes, and I am on my host. And this is fine. This is nice, but I need to have 3 instances. We'll be working on the 3 instances. So having 3 windows over here, it's not the best solution. So I will use VC code to access my servers. Okay, so I show now. So this is VC code, and again, I will just access my server by issue the command. Okay, this is the one. Next, I am clicking on the plus sign, and I'm going for the second one. So now I will go to worker 1. Connect. And I do the same. Okay, and now for worker 2. Great. Now, before we go to the subject of today's video, we need to do some housekeeping on the hosts. So first of all, we need to make sure that our system is up to date. Okay, so we're going to the first node, and actually before that, I will actually want to know which host is which. So what I will do, is I will change a hostname. So it's sudo hostnamectl set-hostname and the hostname you want to use, which in this case is master. Okay, and as you can see, nothing changed. And in the most of the videos, the people will ask you to close the terminal and reopen to see that change took effect. However, there's a simply other command which is exec bash. And there you are, our hostname has been changed. So now let me do this on the other hosts. So this is worker one. And this guy is worker 2. Okay, we do the clear so you can see better. Now let's make sure those hosts can talk to each other. So we need to modify a host file. So how to do it? Sudo vi etc hosts. Okay, so this is the vi tool. Now we go to the last line by the arrows, and then we press I on the keyboard. I is for insert, and now we just need insert our IPs and the host names. So this. Now to save the change and exit VI, you just press escape, WQ. Okay, and let's do this in the rest of the hosts. And again, you can use Nano if you prefer Nano editor. Okay, so let's check if that change works. If we do the ping, -c, the number of packages sent, let's set 5, and now worker 2, we see we have a response. Let's check for the worker 1. All packages going through. Just to make sure, let's do ping -c4 master. So we have a connectivity between our nodes. Okay, so now what we need to do, we need to make sure our system is up to date. So on all nodes, I will issue this command: sudo atp get update and sudo atp get upgrade, and I do -y. -y is forced to answer yes to all the questions. And we have to wait a few minutes, so I will issue this on the rest of the hosts. Okay, over here, just click OK. And we have to do it on all the other nodes. Okay, now once we have our host updated and upgraded, there is a one thing very important which you have to remember. We have to disable swap. Swap space on hard drives is often utilized by operating system as an extension of RAM. Noting data that's less frequent needed to this space to make room for more urgent tasks in the actual RAM. This process, however, results in slower data access compared to RAM. And given the inherited speed difference between hard drive and RAM, I hope that makes sense. Kubernetes, which orchestrates workloads by evaluating the resources at its disposal, may encounter challenges in making precise scheduling choices if those workloads being leveraging swap space. This is due to discrepancy in access time between RAM and swap space. As a consequence, disabling swap is advised prior to setting up Kubernetes to ensure optimal performance and decision making. So, how to do it? It's very simple. That command is, let me clear for you so it's better to see. Sudo swap off space A. Of course, my bad. The spelling mistakes will occur. Now, we need to issue this command, which modifies a configuration file to keep the swap remaining off even after system reboot. And don't worry, all the commands, as you're watching now, are available at my blog, angrysysops.com, and I will link that blog, that particular article from the blog, in the description of this video. Okay? And I do apologize because again I have a typo. Yes. And we will perform the same on the other nodes. We are done with housekeeping things. Now we will go through process of setting up and getting our system ready for installation of Kubernetes. In this step, we will create IPv4 bridge. This step is about letting your nodes communicate over the network like they are in the same exclusive club. However, let's see, cat file. And we have to configure overlay and BR net filter. Okay, and then fine. Okay, that's done. So once this is done, let's do the same on the other nodes. Right, brilliant. Now we need to issue this command. Sudo modprop overlay and sudo probe pr net filter. Okay, and what we can do, we can do this. We can bundle those two commands all together and execute. Execute. Now, in the next step, I will set up some parameters. Okay. And again, this is required for communication between the nodes. So I will do the same. I will do the same on the rest of the nodes. Great. And now we need to apply those settings without a reboot. How to do it? It's very simple. It's sudo sysctl -- system. Brilliant. Now, this is the main part. Now we are going to install Kubernetes components like kubelet, kubeadm, and kubectl. To initiate the creation of Kubernetes cluster, it's essential to install those components on every node. Kubelet serves as a node's agent operating on all nodes to ensure that containers within a pod are functioning according to the pod's defined specification. Pods represent the smallest unit that can be deployed with Kubernetes cluster. Next, the installation of kubeadm is necessary. This tool plays a role in initiating the Kubernetes cluster, preparing a master node, and facilitating the integration of worker nodes into the cluster. kubectl is a command line interface tool for Kubernetes. Enables the execution of commands for various tasks, such as deploying applications, examining resources, and controlling cluster operations directly via terminal. Prior to the installation, it's crucial to refresh the package index, which we will do now. Okay. Okay. And okay. Now, it's imperative to establish a secure environment for downloading and installing packages from internet. To do so, let's issue this command. Sudo apt get install -y, so the answer will be yes for all the questions. Of course, of course, of course. If it hasn't been set up yet, the next step involves creating a directory dedicated to storing a unique key. This key plays a crucial role in confirming the authenticity of Kubernetes packages, similar to how an ID card is checked before granting entry into the security facility. So let's check this by doing this command. Okay, sudo mkdir, let's create a directory. I see it's already there, so we don't need to create, but to show you, yeah, file exists. Okay, so next we will retrieve the public key from Google and place it in the directory we established earlier. The key is vital for ensuring the Kubernetes packages we are downloading are authentic and have remained unaltered. And this is a command which I will not be typing, I'll just copy that. And again, all the commands are available in my blog in the article for that video. Press enter. And we have to do it on the all nodes. Yes. Yes. Okay. Following this, it's necessary to configure the apt package manager with the location of the Kubernetes packages to enable the download. And again, I will just allow myself to copy this. Okay. Okay. And okay. And then clear. Right. And again, we should update the apt index. So let's do it now. Great. With the step complete, we are now preparing to install kubelet, kubeadm, and kubectl. CLT. For stability and compatibility reasons, I will use a specific version, which I worked with that version before. However, if you don't want to lock yourself in that particular version, you can just use this command, which I will issue in a few seconds, without any index. So let's do this. Sudo apt install -y. Now kubelet, and now I issue the version I want to download. But if you don't want that version or want a different version or no version, you just use a command with just a kubelet, without equal and without the version. Kubeadm and kubelet equals the same version, 126.5.0.0. Okay, and as you can see, now the packages are being downloaded and are being installed. So let's do it on all the nodes. Perfect. And perfect. Clear. Clear. And clear. Now, because I wanted the specific version, I will issue the command apt mark hold kubelet kubeadm kubectl. This command is used to prevent these specific packages from being automatically updated when using apt get upgrade or similar command to update other packages on the system. By making those packages as hold, you ensure that your Kubernetes environment remains stable and consistent, avoiding potential compatibility issue or disruption that could arise from unexpected updates or critical components. This practice is particularly important in the environments where specific version of kubelet, kubeadm, and kubectl have been tested and verified to work well together, ensuring cluster performance and reliability. Okay? And of course, what I forget, guys? I forget to add sudo. Boom. Okay, now you can see all three components are on hold, and I am sure this won't change and this won't affect my environment. Okay. Oh, sorry. All right. Time to install Docker. Why? Because Kubernetes loves its containers. Docker provides a platform for building, sharing, and executing application in containers. The container delivers a streamlined and portable framework, guaranteeing uniform functionality across different environments. As the underlying container runtime for Kubernetes, Docker enhances the streamlined orchestration and development of applications encapsulated in containers. You can use a different engine, but for this purpose, for this video, I am using a Docker. So it's very easy. The command is very straightforward. Okay, and the command is sudo install docker.io. And what typo did I make? Sudo apt install. Yes. Docker.io. There you are. Oh, I forget to force Y as well. It's okay. Right, perfect. So sudo apt install .y. Docker.io. Oh, all right. Right. Clear. And clear. It's crucial to set up containerd across all nodes to guarantee its alignment with Kubernetes requirements, beginning with generating a directory for configuration file using this command. Sudo mkdir make directory etc sorry. Okay, and we will do this on the all nodes. Right. These steps ensures that the container runtime environment is properly configured for seamless integration with Kubernetes. Now, we need to generate a default configuration file for containerd. And the command to accomplish this is as follows. Sudo sh -c containerd config default etc okay, I was too quick, guys. So I forgot to close. All right, and let's copy that to all other nodes. Perfect. This action creates the config.toml file within the previous established directory, setting up containerd with standard configuration suitable for future customization. Following the execution of those commands is necessary, and guys, I mean, this is necessary to adjust the config.toml file by finding the line where systemdc group is set to false and altering this value to true. Again, this is very crucial. This adjustment, I cannot stress enough, is crucial as Kubernetes relies on all its components, including the container runtime, to utilize systemd for control groups, C groups. This ensures that Kubernetes can efficiently manage system resources for containers. So I will issue the command now, and the command is this one. And again, I will put this command. This command is available on my blog. All right. Mm-hmm. Right. Two applied modification we've just made restart the containerd and kubelet services on all nodes. This ensures that the changes take effect and that both services are running with updated configurations, maintain the smooth operation for our Kubernetes environments. So we can do this. We can combine two commands, and this will be sudo systemctl restart containerd dot service and end sudo systemctl restart kubectl service. Not kubectl, guys. I'm sorry. I was like few steps ahead. Kubelet. Of course, kubelet. Yes. Again, I do apologize, but as you can see, it's a live demo. So these things are due to happen. All right. Okay. It's not easy to set up Kubernetes. It's a lot of steps. So let me just grab a sip of my tea. Now, once we restart those services, we need to ensure the kubelet service automatically starts with the machine. So let's use this command. Sudo systemctl enable kubelet.service. What did I? Of course. All right, and we have to do it on all nodes. Right, great. Now, guys, it's very exciting time because this is the time to start initiating the Kubernetes control plane with kubeadm. Okay, so this process results in deployment of several key components that are essential for the cluster management and orchestration. Among those components are the kube API server, kube controller manager, kube scheduler, and more, like kube proxy. To ensure those components are available for your cluster, it's necessary to download the images. This is accomplished by very straightforward command, and we need to do it on all nodes. So the sudo kubeadm config images pull. Okay, as you can see, it start pulling images. I will issue this on all the nodes. Great. Now we are ready to initialize the master node of our Kubernetes cluster. Let's do this. So, sudo, and this is done only on the master node. Kubeadm init. Now, pod network CIDR equals, and now guys, it's up to you, but I'll be using this network, which is private network, obviously. Okay, pod network CIDR 168. Okay, I will see that initializing starts, and this is the. It will take a few moments, so please be patient. Okay, and a few things we need to note. Okay, I just put this a big back. So you see this. To start using your cluster, you need to run the following as regular user, and we see this command. Also, you need to note down this command. So we can copy that command. This is a token for your worker nodes to join your master server. Okay, so we put it down on the notepad somewhere, and let's do the commands which we were asked to run. Perfect. Now we need to configure, and this is crucial as well, and this is the part where many failed, but we need to configure the network plugin. And I will be configuring network plugin called Calico. However, there is many more. There is a WaveNet, Flanner, Clickum, loads of those components. I'm just using this one as I was working with them before, and I know how to set it up. But please, you can guys experiment with different ones. So the first thing we need to do is to run the command to initialize the deployment of Calico operator. Okay, and again, this is done on the master node. Now, once we issue that command and we see that everything is fine, we need to proceed to download Calico custom resources file, which includes the definitions for the diverse resources Calico employs. So again, I will just copy the command and it's been done. As you can see, this flag over here, yes, the flag in cure command is used to save the download file with its original file from the web server. The last step is instruct kubectl to establish the resources outlined in this YAML file by executing this command. kubectl create -f custom resources dot YAML. Okay, and we see that's been created. After setting up the master node, we can proceed to incorporate worker nodes into the cluster. During the master node initialization with kubeadm, I showed you the token was generated, which is essential for linking worker nodes to the cluster. However, if you didn't note that command, you didn't know the token, don't you worry, I have your back. What you need to do in this case, if you forget that one, because if you didn't, you just use the command and you join the workers. But if you forget that token, it's simply kubeadm token create print join command, and you can see that token being generated, and the whole command is generated for you, so you don't need to worry. You just need to copy this command, go to worker, paste, and click enter. And of course, don't forget sudo, and there you are. This node has joined the cluster. Yoo-hoo! So we have it. Let's do it on the other node. And we wait a few moments. Yes, the node joined the cluster. So now, to verify it, let's go to the master node and let's issue few commands. Wait, let me clear this first. Let's kubectl get nodes. And you can see all my nodes are here. Kubectl get all. You can see my service. Kubectl get pods. There you are. And you can see there is my Calico API server, there's a systems, this is my Kube API server, everything is up and running. And guys, following my guide and reading the article step by step, you will get your Kubernetes cluster up and running with no time. You've just unlocked a new level in DevOps game, and your applications are thanking you for it. Kubernetes isn't just a tool, it's your ally in the cloud-native battleground. Angry admins, thank you for sticking with me through this tech adventure. If this guide helped you with Kubernetes beasts, smash the like button, subscribe, and hit the bell for more tech tantrums resolved. Until the next time, keep those servers unangry and your code clean. Bye.